Alrighty, problem number 6. Again, still no calculator. We want to find the zeros of this function. If we could use a calculator, we could just calculate the zeros, but we're not doing that because we don't need them. Let them sleep. They get enough use. So let's look at part A first. Find the zeros of this function. So we talked about this on block day. Anytime you see 1, whoa, I tried to write a 1 there. Anytime you see 1, 2, 3, 4 terms, you should be thinking, I'm going to try factoring by grouping. And so, if you recall how that works, you need to look at this function, this polynomial, in two distinct pieces. Separate it into the first two terms. Ooh, that was a bad minus sign. And the second two terms. So, now, once we've done that, you need to go through and you need to factor out the greatest common factor from the blue set of numbers and then from the red set of numbers. This is actually going to be like, piece of cake because it's the same in both. If you notice, they both are 3 and 15. Well, a little different, but blah, 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 whatever. What I'm saying is, from the blue function, both of these functions have at least an x squared. That has an x cubed, but that's like, one more than x squared. And both of them have a factor of 3. So I'm going to pull that out of each of them to get 3x squared. But then I'm left behind with, well, ask yourself, what do I need to multiply 3x squared by to get back to 3x cubed? Well, again, notice we've got a 3 and a 3. We've got 2 x's here, and 3 x's here. So I need to multiply that by x. So that tells me I need to put an x in there. And then ask yourself, what do I need to multiply 3x squared by to get 15? Well, if I have 3x squared, and I want 15x squared, I need to multiply 3x squared by 5, because 3 times 5 is 15. So I get a plus 5 right there. Now, it's almost the same thing here, except this time I can factor out that 3 still, but notice my last term doesn't have an x, so that's all I can factor out. So I'm going to pull out that 3, like that, and then just like before, what am I left behind with? Well, I'm left behind with, I guess I'm left behind with a negative x still, because of that negative right there. And I guess I have a negative 5 instead of a positive 5. So that kind of stinks, because if you recall, our goal is actually, and I should have a plus sign there now, my goal is to make these two thingies the same, because if I do, then that means I have two expressions that share a common factor. So let's try this. Instead of pulling out a positive 3, let's pull out a negative 3, because if we do that, it keeps moving, it's annoying. If I do that, pull out a negative 3 instead, well, then that's going to make that a positive x, like that, and that's going to make that a positive x plus 5. Oh, okay. So now I have x plus 5 and x plus 5 in each of my two terms. Term 1 being 3x squared times the quantity x plus 5. Term 2 being negative 3 times the quantity x plus 5. Well, just like we did there, factoring out GCFs, I can factor out the GCF of those two terms together, which is crazy. It's awesome, and we're doing it. So I'm going to pull out an x plus 5 from each of these two terms, because notice, it exists in both of them. So now you got to ask yourself, well, if I have an x plus 5, what do I need to multiply that by to get back to where I started? Well, you need to multiply that by your 3x squared and your negative 3. Because that's what got left behind, and you need to fill in the pieces. So that's interesting. We just went from subtraction to multiplication. That's pretty cool, because now we want to find these zeros, so I can set it equal to 0, set the y value equal to 0, and solve for my x values. So I'm going to do that. I'm going to take each of my factors separately and set them equal to 0 because of the ZPP, the zero product property. So I get two equations here. Let's look at the left one first. X plus 5 equals 0. I want to solve that for x. Well, that one's a piece of cake. X equals negative 5. So that's one of my zeros. This one, well, first off, I noticed that my 3x squared and my minus 3 both have a 3 in them. So I'm going to factor that out, or in this case, actually, I'm going to divide by them. And that's going to become x squared minus 1 equals 0, because 0 divided by 3 is still 0. Cool, cool, cool. I like it so far. Now I have x squared minus 1, which is a difference of squares, which says I can rewrite it as x plus 1, x minus 1, because that will eliminate my middle term, so Lair won't yell at you. He doesn't yell, he's super nice. But that tells me that I have zeros at plus or minus 1. So altogether, all three of these zeros are happening at negative 5 and plus or minus 1. And I think that's all I was supposed to do is find the zeros. Yep, we did it. We're awesome. Cool. Let's look at this one. Same idea here. We want to find zeros. Anytime you want to find the zeros of a function, just set that function equal to 0. So let's do that here again. Instead of saying y equals blah 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 over blah blah blah, let's say 0 equals blah 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 times or over blah blah blah. But that's weird, Mr. Reed. That's still a fraction, and in class you didn't say we had to deal with it that way. Well, you're right, I didn't. In class, I just said set the numerator equal to 0, because if you have 0 over any number, it's equal to 0. The entire fraction is. I said it. Maybe you believed me. Maybe you didn't. But now I've got a little monster here, and I don't know what that is, but I guess it's a gross beard. But anyways, I said that because of this fact. First off, get rid of this dude. He doesn't need to be there. Let's get rid of that, because that's silliness. You can't just, set part of a function equal to 0. But what can we do with a denominator? Well, if I have x over 2 equals 4, how do I get x by itself? Well, I multiply by 2 on both sides. Ooh, 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 just like that. And then my 2's are going to eliminate each other, and I'm going to be left with x equals 8. Well, we can do the same thing here. I can multiply by x minus 2 on both sides. Oh, see how I totally just stole that b. And if I do that, let's simplify the right. Oh, well, numerator, denominator, but flip those because I totally just said those backwards. Numerator, denominator. Man, my pen's like starting to not work. And then on the left, we have x minus 2 quantity times 0. I don't care what x minus 2 ever equals. It's being multiplied by 0, which means, sorry dude, it's still equal to 0. So really, we have 0 equals the square root of 2x plus 6. And so, we can square both sides, and 0 squared is 0, and the square root of blah 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 squared is just blah blah blah. So I get 2x plus 6. Whoa, that's a 6, not a 2, Mr. Reed. 2x plus 6, solve this equation for x, and we're going to get negative 6 equals 2x. Yikes. And then we're going to divide it by 2, so we're going to get negative 3 equals x. And that is the one and only 0 for this function. But if I was being a jerk and also told you to tell me the domain, how would you do that? Well, you would need to partially look in the denominator Because remember before we were like, hey, remember that you can't actually divide a number by 0? Yeah, that still applies. So look at that denominator. The x value of 2 would make that denominator equal to 0. So x cannot, equal positive 2. Now, if I didn't have that square root in the numerator, we'd be done. Alas, I do, and we're not done. Because not only can you not divide by 0, you can also not take the square root of a negative number. So, that tells me I need the, let's go new color. I need the argument of my square root, the 2x plus 6, the stuff inside the square root. I need that to be greater than or equal to 0, because square root of 0 is 0, 0 divided by negative 2 is 0, so that is in our domain. So solve this inequality for x, subtract 6 from both sides, so we are going to get a positive, and I don't remember where I left off, but I know that this is going to be x is greater than or equal to negative 3, because 2x plus 6 and the 2x plus 6 right there. Only difference is we have an inequality here, so our domain is going to be x, let's just go with it. X value is greater than or equal to negative 3, and x also cannot be equal to 2. So I know that this point right here, that 0, that is actually the starting point of my function. And that kind of makes sense based off of what we know about the square root function. Whoa, alright, last one. Here we go. Let's find the zeros of this thing. So again, to do that, I'm not going to show it this time. We're going to end up with the same thing just like we did last time. We're going to end up with our numerator set equal to 0, because that makes a fraction equal to 0. So let's go ahead and solve this. And in order to do that, I want to factor out the GCF, so I can factor this and make it easier to see the zeros. So I'm going to pull out an x, and I'll be left with an x minus 3. Check me on that. But that tells me then if x, whoa, that's not working, it's annoying. If x equals 0, then this function equals to 0. Or if x equals 3, then this function is equal to 0. And it doesn't exist at the x value of 2, so x cannot be equal to 2 if we want to talk about the domain.